Hello, fellow student programmers. Today we're going to embark on an exciting journey through the land of MongoDB, a popular NoSQL database. We'll explore 10 key concepts starting from the basics and gradually increasing in complexity. By the end of this tutorial, you'll have a robust understanding of MongoDB's capabilities, including queries, data manipulation, aggregation, indexing, and even joins. Understanding these concepts will empower you to build efficient, scalable, NoSQL-backed applications. So, gear up for an insightful session, and now let's dive into the code. Starting off, the first line of our code, db.collection.find, represents the most basic query in MongoDB. This command fetches all documents from the specified collection. It's equivalent to a select asterisk in SQL. But remember, MongoDB is schemaless, meaning documents in the same collection can have different structures. Next, we introduce document insertion with db.collection insert1. This command adds a new document to the collection. Unlike SQL databases, you don't need to define columns upfront in MongoDB. Data can be inserted directly. The third concept, updating documents, is showcased by db.collection.update1. This updates the age of a document where the name is John. The $set operator is crucial here as it specifies the fields to be updated. Deletion is handled through db.collection.deleteone. This command removes a single document matching the condition. It's straightforward yet powerful, allowing for precise data management. Aggregation starts simple with a $group stage in db.collectionAggregate. This groups documents by age and counts them, illustrating MongoDB's ability to perform complex data analysis with just a few commands. Filtering is added to aggregation through the $match operator, seen in the pipeline that filters documents by age before grouping them. This demonstrates how MongoDB can combine data filtering and aggregation for more insightful queries. Projection is used in db.collection.find to control which fields are returned by the query. It highlights MongoDB's flexibility in data retrieval, allowing clients to receive only the necessary data. Indexing, a critical performance feature, is covered by db.collection.createIndex. Indexes support efficient query execution, reducing the need for full collection scans. Joins in MongoDB are handled through the $lookup operator, as demonstrated in the aggregation pipeline joining two collections. This feature allows MongoDB to reference data across collections similar to SQL joins, but maintains the NoSQL approach of embedded documents. Lastly, a complex aggregation showcases multiple stages: filtering, grouping, and sorting the data. This final example epitomizes the power and flexibility of MongoDB's aggregation framework, capable of processing and summarizing large datasets in various ways. Throughout this tutorial, we have explored MongoDB from basic queries to complex aggregations and joins. These concepts are fundamental not only to MongoDB, but to understanding how NoSQL databases differ from traditional SQL databases. We've covered extensibility, as shown by MongoDB's schemaless nature and the ability to handle different types of data and queries. Reusability is highlighted through MongoDB's operators and indexing features, allowing for efficient query patterns that can be applied across different datasets. Efficiency is evident in MongoDB's performance optimization capabilities, such as indexing and the powerful aggregation framework. Thanks for watching, everyone, and don't worry if you missed anything. We've added a link to the source code in the description. If you found this video to be helpful, please like and subscribe for more of the same. Thanks again, and remember, we're always learning, so keep coding, keep exploring, and keep building amazing web applications.